If you roll a dice once, anything can happen. But what if we rolled it 1,000,000 times? Would it behave exactly like the math says it should? Today, we're going to simulate rolling a dice thousands or even millions of times using Python.
Let's simulate rolling a dice, not just once or twice, but 1,000 times or even 1,000,000. Here's the code. First, we import the random module to simulate the dice rolls. Next, we create a function called rollDice. It takes the number of rolls we want. Inside, we set up a dictionary to track how many times each side of the dice show up. Then we roll. We use a loop that runs as many times as we want, and on each loop, we pick a random number from 1 to 6, just like rolling a real die. We count how many times each side appears. After rolling, we call the print results function to display the stats. It shows how many times each number came up, and even what percentage of the total rolls that is. And at the bottom, we have the main function where you can type in the number of rolls you want. Try it with 1,000, or go crazy and try 1,000,000 rolls. Watch what happens after enough rolls. The results get closer to 16.67 for each side, just like probability predicts. This is a simple way to visualize randomness and the law of large numbers. Now, let's run the code. Let's say I wanted to roll just 1,000 times. As you can see, side 1 rolled 173 times, side 2 158 times, and so on. Now let's run it let's roll it 1,000,000 times. As you can see, everything is close to 16.6.
So, check this out. As we roll more and more, the percentages start to even out. That's called the law of large numbers. It basically says the more times you repeat a random experiment, like rolling a dice, the closer your results get to the true probability. So even though dice rolls feel random at first, over time it evens out about 16.67% for each side on a fair die. Small numbers, super random. Big numbers, predictable patterns appear. So, that means randomness isn't as random as it feels. The more trials you run, the more predictable the results actually become. That's why casinos, insurance companies, and even weather models rely on this math. Try this out yourself. Tweak the code, roll more dice, see what happens. The code is in the description. And if you like this experiment, make sure to check out my other breakdowns.